Tola, are you with us?
I am. Can you hear me?
We can hear you. Okay, sorry for starting at a bit of a delay, but the floor is yours. Take it away.
Great. Thank you so much. I'm going to jump right into it. This talk is called exactly what it says right there on the screen, an unreliable information store. And, perhaps ill-advised, I decided to, in sort of looking at all the other talks, I decided to sort of switch my slides up a little bit. Probably not the smartest thing last minute, but I think you can do without another RAG code walkthrough. And so to frame this talk, I'm going to try to focus on what we can do to sort of bring consistency, faithfulness, relevance to large language models for the practitioners that are actually struggling through this and hearing all kinds of new ideas through this fog and sort of this entire transformation in this technology. I want to at least sort of empathize with you. I'm going through the same struggles. I'm Noble Ackerson. For my full-time job, I work as a director of product in Virginia. And what is a director of product doing? Talking to you guys about large language models. I'm a TPM, a technical product lead. I founded a company previously called Biden Atom Research. We shipped a Google Glass-based app a long time ago, and we're still doing a lot of product research and product delivery. So we're not just an R&D shop. We actually sort of ship product. But for my full-time job, that's a consulting gig. But for my full-time job, I actually sort of take some of these practices and apply them to sort of the federal space with Venterra. We're based out of Washington, D.C., or right outside the U.S. nation's capital. Let's jump right into it. I'm going to ask a question. I'm not going to be looking at the chat because I'm sort of locked in here. But I'd like to ask, what do some of these items on the right over here, like Google Glass or 5G, crypto, genetically modified organisms, that kind of stuff have in common? What do sort of nuclear power, crypto, GMOs, NFTs, what do all those have in common, right? Take a beat to sort of think about that, and I'll probably sort of walk you through that. So we're talking about things like nuclear power. As you're thinking about the answer to this, sort of think Fukushima, or Chernobyl. GMOs, think about how you feel when you hear GMOs in your food. NFTs, don't mock it. There's a lot of impressive technology that powers crypto. I'm not into crypto, but I understand the underlying technology is extremely impressive. But there's a common thread here, right? After Chernobyl, maybe Fukushima, public fear overshadowed the efficiency of and the what they call the low carbon efficiencies of nuclear energy. It was shut down in the case of Fukushima. GMOs have a potential to improve crop yields, improve the lives of many. But those technology marvels are mired with the potential risks, not enough guardrails, not enough checks. Crypto just, during the pandemic just went to meteoric rise. I was on the sidelines while everyone tried to revolutionize the financial system. However, it was so complex and versatile. But the entire common thread here, whether it's Google Glass or NFTs or self-driving cars, has a common thing. It's a lack of data trust, right? So all of the hard work that we're doing to bring to bring large language models into production may not even matter in the narrow sense, but collectively for all of us, we can't cut corners. We include that added complexity, but it pays dividends for the entire ecosystem. So that's sort of the frame of this conversation. I've said data trust. I want to sort of define it, and I define data trust in the context of AI as the sum of, your responsible delivery of an integrated deep learning or machine learning model, the continuous value that you deliver by being transparent in what the model can and can't do, for example, in a production setting. and some of the checks that you put in to not just to deliver value, but to sort of protect your end users, and the consequence acceptance, because something will go wrong. But the consequence acceptance from your end users, if because they believe that you're responsible in how you deliver it, and you provide reliable value delivery in this. So you're essentially calibrating your end users' trust. And so that's sort of the first lesson. And so today, hopefully that is a coherent thesis that sort of guides us through the journey that I'm going to take you today. And, I'm going to sort of start with sort of a field report of sorts, like, how my customers are using large language models. Some of so it won't be too surprising. You may already know some of this. We're going to talk about, why generative AI is unreliable. As far as why I feel we shouldn't use it as a zero shot information store. And I'm sure a lot of you guys aren't doing that. But there's a reason why I framed the entire thesis behind that and what to do about it. So yes, these systems are super powerful, yet they're flawed. And we acknowledge this fact today. And so today we're going to sort of talk about where it fails and what to do about it. And in order to walk us through those, I've sort of, the failure points are many. When you're dealing with a non-deterministic system, there's so many areas where the system can fail. And so I've sort of broken this up into, the data input, your system IO, and of course the product input, which is where typically your users will interact with the tool. And so I'm going to start at the end. We'll Quentin Tarantino this thing and start from the product output and work our way back. And product output meaning, you have an interface with your end users. So it's your user experience. You're also probably doing some testing and some evaluation with your experts in the room. And so it's also developer experience focused in this sense. And just to sort of frame that even further, even though I, as a practitioner, I've been working with machine learning, or at least NLP models since 2016 or so, when Spacey was pre 1.0 or whatever it was. My first interaction with a generative AI was in February of this year. And as I do with every new technology, I went ahead and ego surfed and typed in my name and realized that, Bing had just announced they were going to sort of launch generative AI features into Bing, and Google was following suit. And that terrified me, right? And so I started wondering, we use these tools. These tools are built to model language, right? That's why they call them language models, right? They're autoregressive, meaning they're trained to generate text. They're rewarded by predicting the next coherent word in a sequence. They're non-deterministic by nature. They're probabilistic by nature. They do not reason deductively natively without additional help or access to other things or other language models, that kind of stuff. And they're epistemologically blind to what they don't know. So given a prompt, you may get a very unpredictable answer, right, every single time. And the notion that an autoregressive system that lacks deductive reasoning, that is blind to what it knows, being incorporated into the enterprise also terrified me, right? And this is where I work. So I decided to sort of put together a couple frameworks and sessions and sort of slow my customers down before we went full bore in integrating these powerful tools into our system. Because there's also a cost associated with this. The cost for my customer who doesn't have the deep wallets of a Google or Microsoft or an IBM to ship a generative AI solution without consideration of factual correctness, repeatability, consistency, reliability, that kind of stuff is too high, right? So we require guardrails, we require tests, we required human experts in the loop, people, humans on the loop as well to provide feedback to get that flywheel to further improve your model. And these are some of the use cases that we see. It might be a combination of some of these, say, for example, an RPA project that robotic process automation project that is now LLM powered that I just shipped for one of my Byte and Atom research customers, for example, combined a few of these different categories. There's so much complexity that I empathize as we sort of saw our way through this process. As we added more complexity, internally, it fell short every single time. It felt like our customers, the feedback that we got felt like they were yelling at a PA system or a wall. And so, we started at base zero. All right. So maybe we shouldn't use ChatGPT. Maybe we should use an API-based system. And surely enough, we didn't go with ChatGPT, the OpenAI API, even though that's what I'm showing you here. We went with a Google offering with the Palm, the Maker Suite playground. And still the same thing, added complexity, falls over when we put it into production, users complain, they feel like, they were yelling at a wall. So they don't use the app because it's unreliable. They do not trust it will be consistent, and then it fails. But we can't cut corners, and so we add more complexity. We start thinking about ways to version our prompts, and there are a bunch of talks today that will sort of talk about that, or have already. There are ways to sort of frame and better write your prompts, all right? And as a creative technologist, as a product mind or product leader, I start thinking about what came before us, and I think you should as well. In the late 60s, Paul Rice identified something he called the Cooperative Principle. And I think that this is a powerful frame as you go forward with your product outputs and sort of create prompts and hopefully version them and follow the best practices that you've heard about all throughout the day. He talks about 4 maxims. He talks about quality, which is focusing on how truthful we are with each other. He talks about quality, how informative we are, relevance, and manner, how clear we are, right? And so, these can be used as reliable guidelines when when you're doing your in-context learning strategy or how you frame your prompts. For example, like when engineering prompts for a large language model, the maximum for relevant is super crucial. You should craft your prompt directly related to the task at hand, rather than tell me about AI or who is noble. Something like explain the key principles of machine learning is perhaps better. We are not here to learn about how to craft a prompt. So let's switch directions a little bit. I want to sort of attack the complexity paradox in a different way, a little bit more practical way. There are many failure points for these tools. I've mentioned maybe 3 here. There were more, but I've sort of whittled it down, it seems. Overfitting, that comes into play today. Those who've worked on this machine learning in the past, our old friend is back when you want to fine tune your larger data sets, or at least if you don't have enough data, you will find your model's not generalizing well. Probability, it comes from the foundation model and sort of carries over, with the knowledge gaps therein. And so back to this sort of framework, we're sort of working our way back with the systems, and we're going to sort of talk about some of the system input and some of the data outputs. So with, trying to get consistency by teaching your private data new tasks, by leveraging large language models. Simply put, overfitting occurs when your model fits exactly against your training data. Essentially, you want to mitigate that by reducing the variance between your error and the validation data set. It's not generalizing well, like I said, and so I'm skipping the code part, and so we're just going to jump right in. I'm sure it'll show a sort of framework how everything comes together a little bit, sort of jump to the end. Lots of hype, like I said, demos do well, but they fall over once they get into production. Here you see sort of a serving framework that I designed, and that works for me. Your context might be different. Your data sources get prepped, across this is your reliable information source. This is your domain information. You can add feedback data for your flywheel, your model improvement flywheel, your red and purple teams might appreciate some telemetry data that you may feed them. But the point is to version that data, to feed that into your system, to teach it new knowledge. You may want to, like I said, fine tune, or perhaps not. You may want, you may have too much data. You may want to have a distributed transfer learning pipeline to sort of fine tune multiple models at the same time. You've got online evaluations. You've got performance tests. I'm sharing this to say, before you integrate and have the benefit of, selecting the best performing model and doing your post-processing to sort of persist your chat history for longer conversations, that kind of stuff. There's a lot that goes into this in a batch sense before you're streaming into your front end application. And so the drawbacks are simply, overfitting is, our old friend is back. If you have a small data set, you got problems. The cost is really high, because a lot of people sort of think that initial cost, you're spending somewhere close to $2 million just to get, depending on your scale, it might be less, to get everything up and running. But we forget that there's an OpEx, there's an operational expense to continue training as your data changes. Data changes in the enterprise, by the minute in most cases. Ethical risks don't just stop because you fine-tuned your model, right? So without guardrails, you have some issues. And also notably, these models sort of, have a point where they stop training. So your fresh data, this is where RAG comes in. So another demo that I was going to give you, we're going to skip that as well, because, I recommend you going to Rahul in our community, who's got a course on this matter. But we sort of take from that pipeline that you saw and sort of bring it into a streaming context, right? And then we sort of give feedback back to our batch pipeline that you saw before. I'm going to skip the code. Complexity paradox. So what do I mean by that? So I began with these LLMs are powerful beasts, right? We know they're super powerful, but yet we put in the work to make sure we constrain them. And it's very important because they can get scary, right? And when we find a technique that works for our context, we make them a little less beastie and more friendly. And we add a lot more to a lot more content, a lot more hard work, a lot more complexity, a lot more cost that goes into making these things safe. Yes, I should acknowledge that if you have money of a nation state or Google or Microsoft or whoever, OpenAI certainly, you can probably train your own LLMs. But for my customers, we don't have that luxury. And so just to land this plane, I've enumerated a few areas across the, data input, the system output, and the product output. These are some mitigation tactics that we tend to use. If you're looking for a little bit more meat or code, I'm going to share my GitHub here at the bottom left-hand corner, and I'm going to be doing a lot more YouTube videos by request. And so I hope this has been useful. I hope I'm on time. I was not timing myself, and so I'm going to hand it off to Adam.
You're doing good. You're on time. And also your book. So you're writing the book. It's coming up?
Yes. Practical data trust for AI. Oh, I called it Practical Data Trust for ML AI Practitioners. And that's because I was writing the book long before the generative AI boom. But I think it really matters because a lot of my customers still work on traditional ML or narrow ML, as we call it these days. And so, yes, that should be released next year. And so, again, just type in my name on
GPT.
Again, type in my name on the socials, and you'll probably see me announcing it next year.
Nice. And yeah, I mean, if folks want to follow you on YouTube or your GitHub, I'm sure they'll learn more there. We got a couple of not sure if this is a question, it might be more of a comment, but perhaps I'll address it to you either way. Chris Thompson is saying, so happy to see this laid out. So much is overlooked when deploying LLM apps. Thank you for this talk. And then they continue with, not only do you have ML monitoring, but also user monitoring. The need to address negative trends in user feedback is another crucial aspect to watch for. Then you need eyes on not only the model, but also the output coming from the knowledge store. And robust logging from the code itself. Problems can arise in many different parts of these systems.
Spot on. And one thing that I didn't get into, I hinted at it in the beginning, just to add to that comment, is sort of calibrating trust, right? One, clearly communicating what the system can do. I know I wrote that here, gracefully failing. That's important. But, if I'm optimizing for under trusting my system, people are, it's unreliable. It has factual errors. People are not going to use my tool. And so that needs to be logged and persisted and to help improve your model. If your system is working well, perhaps too well, you have a new paradox, a new problem, which is over trusting, where someone might, if you have a multimodal model that, you can sort of scan a plant and it tells you whether it's safe to touch or not, or eat or not, if it's, too right all the time without any context, without any modalities, or at least any affordances within the experience to let them know to double check, depending on the criticality of your tool, you're over trusting, and that's also not good. You're optimizing for over trusting. So that calibrated trust is sort of somewhere sandwiched in the middle, and it's very, very hard work. It's an art, not a science. And so again, I commend all the practitioners here today to hear from a product mind rather than a classic engineer to sort of think about these things.
Yeah. I'm curious also about the cooperative principle that you put up. Nice quote, by the way. I wonder, do you feel like there is also a possibility or some potential where the fact that we need to be so thoughtful about truthfulness and relevance and informativeness and clarity will sort of like even back influence and add back pressure to the way we communicate with one another too, right? So this is something that feels to me like at least a potential for LLMs, insofar as we have to then focus on improving them so as to facilitate conversation more effectively. What can they then do for us in the way that we converse with one another?
You're right on. I learned this back in March when ChatGPT came around. I'm not a linguist by any stretch of the imagination, but I'm a parent. I've got a girl, a young lady in elementary school, and even to take that a step further, how I interact with my tool. When I picked up this book, Syntax and Semantics, not only was I able to sort of get research for my book, but I was able to sort of realize exactly what you're saying, how to converse with my child, right? How to, and that sort of maps, how clear, how relevant, how informative I am with, with my colleagues and ultimately the machines that we want to get the best out of, right? So
totally. I will smuggle one more question in here because Leonardo asked it, and Leonardo is the champion of the quiz. Leonardo says, no, well, this question is a bit off topic, but in your experience, how do you approach the ideation and development of new products or features with AI, ensuring that the focus starts with the problem to be solved rather than the technology itself? In our squad, we are centered around AI solutions, but as a PM, I aim to create solutions that address real-world issues rather than merely leveraging the tech for its own sake. Could you share some insights or methodologies that help in aligning the technology solutions closely with the problems identified?
I love this question so much, and so I'll be very terse. One, understanding and communicating internally, there's a lot of hype, right? So in communicating internally that the model is not the product, even the integrated model that is being served as an API is not the product, or at the edge is not the product. The problems that we're looking to solve that humans have, whether it be narrow within your part of the world, that humans have that you're looking to solve is the challenge. AI is simply augmentative or maybe autonomous in some cases, and doesn't really solve the problem all the time. And so I guess to enumerate some things to help address the question, one, the old Steve Jobs adage, right? Start with a problem, work your way back to the solution. Let's not do, I didn't rip on crypto, but you noticed with a lot of emergent technologies, I don't care if it's crypto, Google Glass or VR or MR or whatever it is, we get mired by demos and we sell those demos, and we don't look at the systems that that are interdependent. And when I say systems, I'm not talking about technology. Put technology aside for a second and bring in regulations and bring in harms and potential detracting issues from pushing your product forward. Bring in socioeconomic issues sort of falls under that as well. Bring in, other products, right? So that bring in technologies and see how that they sort of interconnect. And once you start framing that and framing your problem right, and sort of thinking from, we call it systems thinking, and sort of thinking about all the dependencies, start forming your principles around that. And your principles may reflect as going back to sort of wrapping this up with how I sort of framed this conversation, your data inputs, having data cards and model cards to better have the lineage, provenance, and understanding as to how the data came to be. Having for your system input and your system output, being able to sort of build on top of machine learning operations. This is the MLOps community at the end of the day. Build on established standards rather than want to sort of roll your own. And then, of course, on the product output side, again, those practices of, protecting your system from bias and explaining what the system can and can't do.
Yeah.
Some of those soft skills will help you afford the trust that you need from your end users. And that's important for not just your product, but for everyone here doing something with it.
Thank you very much, Noble. Leonardo, I hope you enjoyed this answer. This was a brilliant answer, Noble, and very inspiring. Thank you very much for coming to share your wisdom with us.